Welcome. Today we'll solve a challenging integral involving a square root and a rational function. Let's look at the integral of the square root of x squared minus a squared divided by x to the fourth power with respect to x. This integral looks quite challenging at first glance. Let's break down our approach. The presence of square root of x squared minus a squared suggests we should try trigonometric substitution. Let's make the substitution x equals a secant theta. This is because when we have x squared minus a squared under a square root, secant theta is often helpful. Remember the identity. Secant squared theta minus 1 equals tangent squared theta. Let's see what happens when we make this substitution. First, x squared equals a squared secant squared theta. Therefore, x squared minus a squared equals a squared secant squared theta minus a squared, which equals a squared tangent squared theta. Taking the square root, we get a tangent theta. We also need dx, which equals a secant theta tangent theta d theta. Now let's substitute everything back into our integral. Our integral becomes the integral of a tangent theta divided by a to the fourth power secant to the fourth theta times a secant theta tangent theta d theta. Let's simplify this expression. After combining terms, we get 1 over squared times the integral of tangent squared theta over secant cubed theta d theta. We can simplify this further using the identity that tangent squared over secant cubed equals secant minus 1 over secant cubed. This gives us 1 over squared times the integral of 1 over secant squared theta minus 1 over secant cubed theta d theta. Now we can integrate each term separately. The integral of 1 over secant squared is negative cosine theta, and the integral of 1 over secant cubed is cosine squared theta over 2. Finally, we need to substitute back to x. Remember that cosine theta equals over x when x equals a secant theta. Therefore, our final answer is negative 1 over a squared times over x plus 1 over 2 a squared times a squared over x squared plus c, which simplifies to negative 1 over x plus 1 over 2x squared plus c. And that completes our solution. We use trigonometric substitution to transform a complex integral into something manageable, and then carefully worked our way back to our original variable.